Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to discuss how to run two-way repeated measures ANOVA in SPSS, also known as between subjects ANOVA. Two-way repeated measures ANOVA is used when you have multiple measurements for the same subjects. It is useful for analyzing the effect of within subject factors like time or conditions on a dependent variable. When a between subject factor is included, it allows you to compare different group of subjects. Let's try to understand this concept in the next slide. In case of two-way repeated measures ANOVA, we consider the subject variable as time and the subject factor as exercise. So two exercises are considered, cycling and swimming. We want to see the effect of different exercises according to the time interval T1, T2 and T3. Now let's take the subjects. The first subject does the swimming. His weight at time T1, time T2 and time T3. So you can see there is no reduction in the weight. The second subject does the swimming. So his weight at time T1, T2, T3 and here also there is no reduction in the weight. So we can say that cycling and swimming does not reduce the weight according to the first case. Let's take the second one. Cycling, the weight at time T1, weight at time T2, weight at time T3. So there is a significant decrease in the weight. Now the second subject, which does the swimming, weight at T1, T2 and T3. So we are seeing the effect on the weight according to the time and according to the exercise. So this is known as between subject ANOVA. Let's say we conduct an experiment to study the effect of two different exercises, cycling and swimming, on weight loss over time. We measure the weight of the participants at 3 time points. At the start, that is week 0, after 4 weeks, and after 8 weeks. We have two groups of participants, one following swimming and another following cycling. What are the hypotheses which we have to test? We start with the first one, within subject variable. I have already uploaded the video on within subject variable. Kindly refer to my playlist. Null hypothesis, there is no change in the weight over time. Alternative, there is a significant change in weight over the time. So the weight reduction can happen between the time interval T1, T2. So the difference in the weight can be between T1, T2. It can be between T2 and T3. It can be between T1 and T3. So this is within subject variable, the element is time. Now we will talk about between subject effect, which is exercise. There is no significant change in weight between the exercise groups. The alternative is there is a significant change in weight between the exercise groups. Cycling, swimming. We are comparing the weights. Which is the better exercise? Interaction effect, that is time with exercise. The pattern of weight change over time is same for both the exercise groups. The alternative is the pattern of weight change over time differs between the exercise groups, the combination of time and exercise. Univariate assumption which we have to test is normality. The dependent variable should be approximately normally distributed for each condition, time point and treatment. The assumption is particularly important when the sample size is small. With larger sample size, the ANOVA is more robust to the deviations from the normality. Example of the normality, the distribution of the blood pressure readings at each time point. Let's say the time points are T1, T2 and T3. So the distribution of blood pressure readings at each time point should be roughly normally distributed. So we are having some formal testing methods to test the normality. Shapiro-Wilk test for small sample size and Kolmogorov-Smirnov test is for the large sample size to test the normality in the data. The next is the assumption of sphericity. The sphericity assumption, also known as a homogeneity of variance, is meaningful only if there are more than two levels of within subject factors. So we are having more than two levels, T1, T2, T3, the weights taken at T1, T2 and T3. The variances of the difference between all the combinations of the related group conditions should be equal. This I'll explain in the next slide. Example of sphericity, the difference in the blood pressure. Remember the difference in the blood pressure readings between before medication and 1 month after, before medication and 3 months after, and 1 month after and 3 months after. The difference in all these three pairs should have a equal variances. Let's try to understand the concept of sphericity in this slide. Imagine you are trying three different types of ice creams with your friends, different types of ice creams with your friends. You want to know which one they like the most. The types of the ice creams which are considered are vanilla, chocolate, and strawberry. Friends rating, each of your friend tastes and rates all three ice creams. Understanding the sphericity. Consistent difference should be there. Sphericity means that the difference in how much your friend likes each type of ice cream should be consistent. For example, if one friend likes vanilla more than the chocolate by 2 points, so here remember the difference, not the individual rating. The difference in between the rating of vanilla and chocolate is 2 points. Other friends should have a similar differences in the ratings. If the differences are not consistent, why it is important? If the difference in ratings are not consistent, it can be hard to tell which ice cream is actually favorite. Let's take the example. If one friend rates vanilla 10, chocolate 8 and strawberry 6, the difference between vanilla and chocolate is 2 points. If another friend rates vanilla 6, chocolate 9 and strawberry 8, the difference between vanilla and chocolate is 3 points. So here the difference is of 2 points and here is the difference is of 3 points. So we cannot compare. So that is the assumption of sphericity. Now let's say friend 1. The rating of the ice creams are given 8, 7, 6. So this is the rating of friend 1, friend 2, friend 3. To check for sphericity, we'll look at the differences between the ratings for each pair of ice creams for all friends. Difference between vanilla and chocolate. 8 minus 7, 1. 9 minus 8, 1. 7 minus 6, 1. Difference between vanilla and strawberry. 8 minus 6, 2. 9 minus 7, 2. 7 minus 5, 2. Difference between chocolate and strawberry. 7 minus 6, 1. 8 minus 7, 1. 6 minus 5, 1. The differences are consistent. The differences are consistent between the pairs vanilla versus chocolate, vanilla versus strawberry, and chocolate versus strawberry. This is sphericity. Sphericity means that the difference in the ratings between all pairs of ice cream should be about the same for everyone. When this happens, it's easier and more accurate to find out which ice cream your friend likes the most. If the differences are not consistent, it becomes harder to figure out the true favorite. We are having some formal testing methods to test the sphericity. One of them is Mauchly's test of sphericity. This is the primary test used to check the sphericity assumption. It assesses whether the variances of the difference between the conditions are equal or not. If Mauchly's test indicates the violation of sphericity, no need to worry. Corrections like greenhouse gaser are applied to adjust the degree of freedom. The next assumption is of the independence of observations. The observations should be independent of each other. This means that the score of one subject should not be influenced by the scores of another subject. The example of it is the blood pressure readings for one participant should be independent of the readings for the another participant. Now, how we can achieve this independence of observations? This can be done by the study design. The independence assumption is primarily addressed through the study design, ensuring that the ratings or measurements of one participant do not influence those of the another. We don't have any formal statistical test, But it is done. It is done through proper randomization and control in the experimental design. So this example we have already discussed. I'll again repeat it. The blood pressure readings for one participant should be independent of the readings for the another participant. So this we can achieve with the help of proper randomization and control in the experimental design. Now this assumption is a multivariate assumption. Up till now, we have discussed the univariate assumption. See, the normality is a univariate assumption. Sphericity is a univariate assumption. Independence is a univariate assumption. Now this is multivariate assumptions, which is equality of the covariance matrices. The covariance matrices of the dependent variables should be equal across the levels of within subject factor. This is related to the assumption of sphericity, but it is in a broader sense. I'll explain this concept in the next slide. The example of the equality of the covariance matrices is the relationship. Covariance between the blood pressure readings at different time points should be consistent across the participants. Let's take the same example of the sphericity again. Ratings by the friends. Now we will take the mean of it. The mean rating of vanilla. So what it is? 8 plus 9 plus 7 plus 6 divided by 4. It's 7.5. So we got this. The next is the chocolate. 7 plus 8 plus 6 plus 5 divided by 4. It's 6.5. 6 plus 7 plus 5 plus 4. So we got 5.5. So this is a mean rating for vanilla, chocolate and strawberry. Now we will take the difference of it. 8 minus 7.5, 0.5. 9 minus 7.5, 1.5. 7 minus 7.5 minus 0.5. 6 minus 7.5 minus 1.5. Similarly, you will repeat this procedure for chocolate and strawberry. The next thing which we have to do is multiply the differences. See, we want to see the covariance. Just a minute. So what I will do, I want to see the covariance between vanilla and chocolate. So I will multiply 0.5 with 0.5, 1.5 with 1.5, 0.5 with 0.5, minus 1.5 with minus 1.5. This is for vanilla and chocolate. Now for chocolate and strawberry, 0.5 with 0.5, 1.5 with 1.5, minus 0.5 with minus 0.5, minus 1.5 with minus 1.5. So you can see at this we have done it here. So we got 3 by 3 matrix. Now I'll take the average of it. So this is 0.5 into 0.5 plus 1.5 into 1.5 plus minus 0.5 into minus 0.5 plus minus 1.5 into minus 1.5 divided by 4. We got 1.25. So this is the covariance matrix which we got, and the figures are same for all the combinations. Combine these results into a matrix. This matrix we got it. The covariance matrix helps us to understand how the ratings for different ice creams relate to each other. Equality. The figures should be same. The equality of the covariance matrices means this relationship should be consistent across different groups or conditions, ensuring our comparisons and conclusions are reliable. So we are having a test which is a boxem test to check the equality of the covariance matrices. However, it is more sensitive to the deviations from normality and may not be robust for small sample size. Now let's take the case study. 18 individuals participated in a study aimed at checking the pulse rates through various intervention strategies. Each participant had an initial pulse measurement recorded at the beginning of the study. Pulse 1 at time 1, pulse 2 at time 2, pulse 3 at time 3. 3 groups were formed on the basis of exercises: swimming, cycling, and playing tennis. So what are the hypotheses which we'll have to test? The first one, within subject variable, there is no significant change in pulse over time. Alternative, there is a significant change in pulse over time. Between subject, there is no significant change in pulse between the exercise groups. Alternative, there is a significant change in pulse between the exercise groups. Interaction, the pattern of pulse change over time is same for both the exercise groups. Alternative, the pattern of pulse change over time differs between the exercise groups. As we are having an interaction effects, this is the reason we say it is a two-way repeated measures ANOVA. Now let's run this in SPSS. So we are having the same example here. Now I will go in analyze, generalize linear model, not linear models, not S, generalize linear model, activate repeated measures. Now write down here time. So this is within subject. We have already discussed in my previous video. Now add, define, transfer pulse to time 1, pulse to time 2, pulse to time 3. So this we had done. In this video, we are going to discuss about between subject factors. So I will include the exercise here. Click on model, keep the things as it is, no change, continue. Contrast, keep the things as it is, no change, continue. Plots, transfer, exercise, horizontal axis, add, time, add. These are the main effects. Now transfer exercise to horizontal axis and time to the separate line, add, continue. Post hoc, exercise, transfer it here, tucky, continue. Post hoc, exercise, tucky, continue. Estimated marginal means, I want the difference in the pulse according to the exercise, according to the time, and according to the interaction effects. Compare the main effects, keep LSD on, continue, save, keep things as it is, options, descriptive statistics, estimates of effect size, and homogeneity test, continue. Now click OK and you got the output. So we will test the assumptions first. The first assumption, the equality of covariance matrices. So I will click here, right click on it, copy. I copied it in my slide. What was our null hypothesis? The null hypothesis is the observed covariance matrices of the dependent variables are equal across the groups. Alternative, the observed covariance matrices of the dependent variables are not equal across the groups. The p-value is more than 0.05, which is desirable. Since the p-value is greater than 0.05, that is at 5% level of significance, we fail to reject the null hypothesis. This means that there is no significant evidence to suggest that the observed covariance matrices of the dependent variables are different across the groups. This is desirable. This is expected. This you should get it. The results indicate that the assumption of the equality of the covariance matrices is not violated. So the first assumption is clear. The next assumption is of the sphericity. So we will copy output from here, the mock list test of sphericity. Right click, copy. Now what is the null hypothesis here? The null hypothesis is there is no significant difference in the variance of all the pulse at 3 different time points. In simple language, data is having the sphericity. The variances are equal for all the 3 different time points. See the mock list value, it is 0.392, and see the significant value, it is 0.001. Now mock list value close to 1 suggests sphericity. This is this is nearer to 0, it means that the sphericity assumption is violated, while values closer to 0 suggest a violation of sphericity. Since the p-value, this, is less than 0.05, which is 5% level of significance, and Mauchly's value is 0.392, Mauchly's W is 0.392, we reject the null hypothesis of sphericity. This indicates that the assumption of sphericity has been violated. Okay. Next is the table of test of within subject effects. This I can get it from here. Test of within subject effects and test of within subject contrast, this two table. So I'll right click, copy. Now let's do the interpretation. In the test of within subject effects table, this one, when we fail to reject null hypothesis, that is the Mauchly's test, that is the assumption of sphericity, is not violated, the effect of subject is to be done from the first row. See, if we achieve sphericity, let me make you recall. According to this test, if we achieve the sphericity, which means that if this p-value is more than 0.05, if we achieve the sphericity, then the interpretation of within subject effects is to be done from the first row. Okay, let's read it again. In the test of within subject effects, when we fail to reject, in layman terms, you can remember, accept the null hypothesis, that is the assumption of sphericity is not violated. Effect of subject is to be done from the first row observation. In the test of within subject effects, when we reject the null hypothesis, the Mauchly's test, that is the assumption of sphericity is violated. Effect of subject is to be done from the second row observation, this one. It is a correction of sphericity known as greenhouse user correction. As in our study, sphericity assumption has been violated. We do the interpretation from the second row. So just try to recall the Mauchly's slide. Our null hypothesis was rejected. We did not got the sphericity. The main effect of time is significant. See, the time is significant as the SI, the significant value, the p-value is less than 0.05 under all corrections. You have to see all the corrections. Under all corrections for sphericity violations, indicating that the pulse rates differ significantly across the different time interval. Let me repeat again. See, you should get the p-value less than 0.05 for all the corrections. Okay, then we can say that the effect of time is there. Now let's talk about the combination of time with exercise, interaction. The interaction effect between time and exercise is not significant under all corrections for sphericity violations. This means that the changes in the pulse rates over time do not significantly differ between the different exercise groups. Just a small correction. You will have to only see the correction one, the sphericity corrections, not sphericity assumed, as it is already violated. Okay. So the interpretation is, this means that the changes in the pulse rates over time do not significantly differ between the different exercise groups. The next is the interpretation of partial eta square. The main effect of time is significant across all the multivariate tests, that is Pillar's trace is considered important, with p-values all less than 0.01. The partial eta square values for all tests are 0.978, suggesting that the time explains 97.8% of the variance in the pulse rate, which is a very large effect size. Now let's talk about the interaction, time with exercise. Just see the p-values. Sorry, see these p-values. These are the p-values. The interaction effect between time and exercise is not significant across all multivariate tests. With p-values all greater than 0.05, this indicates that the change in pulse rates over time do not significantly differ between the different exercise groups. The exercise groups are swimming, cycling, and playing tennis. Test of within subject contrast, time, linear, and quadratic. See the p-value 0.977, and for quadratic it is 0.464. This interaction effect is not considered because it was not significant. Linear trend. The linear component of time is significant. See the p-value, indicating a consistent increase or decrease in pulse over time intervals. The partial eta square value of 0.977 suggests that 97.7% of the variance in the pulse rate can be explained by the linear trend over time, which is a very large effect size. Quadratic 0.464. The quadratic component of time is also significant as the p-value is less than 0.05, indicating there is a curvature in the change of pulse rates over time. Example, the pulse rates increase initially and then decreases. The partial eta square value of 0.464 suggests that the 46.4% of the variance in the pulse rates can be explained by the quadratic trend, which is a moderate effect size. This means that the explanation of the variation in the pulse rate by linear trend is better in comparison to the quadratic trend. Now this table, you will get it from here. Here is it. Right click and copy the next table. The next table is of Levin's test of equality of error variances. For pulse 1, see the SIG value, pulse 2, pulse 3. For all three pulse measurements, Levin's test yields p-value greater than 0.05 for each method. This indicates that the variance of the pulse rates are not significantly different across the different exercise groups for each time point. So this is desirable. This is necessary to be achieved. Pairwise comparison. See, the difference in the pulse according to the exercise is not there, but according to the time interval it is there. So it is necessary that we go for pairwise comparison. From where I will get this table? This you will get it from here. Pairwise comparison, here is it. So pairwise comparison for exercise and pairwise comparison for time is here. Now let's do the interpretation. Pairwise comparison. The mean pulse rate at time 1 minus the mean pulse rate at time 2. The difference is minus 46.611. P-value less than 0.05. It means that the difference is significant. Mean pulse rate at time t1 minus mean pulse rate at time t3. The difference is minus 102. And the p-value less than 0.05. So this is also significant. Now mean pulse rate at 1 minus mean pulse rate at 2 and mean pulse rate at 2 minus mean pulse rate at 1. The difference will be only of the signs. The p-value remains the same. So there is no point in doing the comparison again. The pairwise comparisons confirm that the pulse rate varies significantly across different time intervals. Time interval 1 consistently has the lowest pulse rate, followed by time interval 2 and then time interval 3. These findings align with the significant mean effect of time observed earlier. We had seen that the effect of time is there, indicating that the pulse rates change significantly over the course of the study, with specific patterns of change between different time intervals. Now let's see the comparison of exercise. Exercise effect was not there. The same thing we can confirm from here also. The pulse rate of swimming, the mean pulse rate of swimming minus mean pulse rate of cycling, it is just minus 2.67. The difference is there. The p-value more than 0.05 and therefore it is not significant. The mean pulse rate of swimming minus mean pulse rate of playing tennis 9.83. So the p-value is more than 0.05, that is 0.724. So all the p-values are more than 0.05, and therefore the effect of exercise is not there on the pulse rate. None of the p-values for the pairwise comparisons are less than the common alpha level of 0.05, that is the 5% level of significance. This indicates that there are no statistically significant differences in the mean scores, the mean pulse rates between any pairs of the exercise groups. Main effect of time. So you can see the pulse rate at T1, the mean pulse rate at time T1, time T2, 134, and at T3, 189. So the pulse rates have increased. Okay, just a minute. So this confirms here also. Time interval 1 consistently has the lowest pulse rates. Then time interval 2 will have a pulse rate higher than 1, and 3 will have a pulse rate higher than 2. Right? Now see the effects, the main effects of the exercise. Swimming 139, cycling 142, and playing tennis 129. So the pulse rates are more or less near to each other, and therefore there is no effect of exercise. These are main effects. The interaction effects: swimming, cycling, playing tennis, and the colors indicate the time interval. So blue is T1, red is T2, green is T3. So swimming at time T1, swimming at time T2, swimming at time T3. Their mean: cycling at T1, T2, and T3, playing tennis T1, T2, and T3. So this was all about two-way repeated measures ANOVA in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.